In this video, we're going to take a look at solving quadratic inequalities using a graph. And let's say that we have two functions, f and g, which you see here. F is in this dark kind of bluish color, and g is in the black color. And let's say we want to know when f of x is less than g of x. That's the same as saying when is x squared plus 3x minus 18 less than 10, because this here is what f of x is and this here is what g of x is. So basically if we want to know when f of x is less than g of x, f of x is your quadratic here. If you look at this, we want to know when it's below, that's when it's less. And it's below starting right here and going all the way over to here. Right here is where they are equal. And that's where the y is equal to 10, because that's what g of x is. And anywhere in between those two is where it is below, which means the quadratic in that area is less than the g of x, which is equal to 10. Now, when you're solving this, notice this equation right here that I've written has only x's in it, so we're concerned about x's. The x right here is -7. The x over here is 4. That's where they're equal. Since this says less than, we want to use a round bracket. If it was less than or equal, we would use a square. Round bracket means we get really close to this -7, but we don't include it. And we want everything that goes up to this 4, but we also don't want to include that either. Interval notation, our solutions would be between -7 and 4, not including those two values. If you were doing set builder notation, since we're solving for x in this case, it would be all x such that x is greater than -7. That's such that, and less than 4 with an ending set bracket. Now, what if we change this slightly? It's going to be the same picture, the same idea. However, instead of wanting to know when g of x is less than f of x, what if we want to know when g of x is greater than or equal, or when f of x is greater than or equal to g of x? Now we want to know when the quadratic of x squared plus 3x minus 18 is greater than or equal to the 10, which is g of x. If we want to know when it's greater than, rather than wanting it to be below our horizontal line of 10, we want it to be above. Notice that it's above the horizontal line in this area here, and it's above the horizontal line in this area here. Now, we're actually solving for x. So if you look at the x-axis down here, that's from 4 forward over here, and we do include 4, so it's going to be a square bracket. And then over here, if you look to the corresponding value on the x, that's at -7. So we would include -7 with a square bracket, but it would be everything before it. Because remember, in between those two numbers is where it's below, so that's when it's less than. In interval notation, we would come up from -infinity, so this section would be -infinity, comma, and we go up to this spot right here, which is at our -7 here. So -7, and this time there is a line underneath our inequality, so we include the -7 with a square bracket. And then there's a huge gap here in the middle, so we have to use a union symbol here. And then we get to the 4, which we do include, so we use a square bracket. And then we go off to infinity. So we finish out with an infinity and a round bracket. And that's how you would take a look at them. You want to determine if you want to know when something is greater than or less than, whether you include the points where they're equal, like we did in this one. We did include the points where they were equal. And then you determine if you want the section of the graph where one of them is above or below on your picture.